Hello, pre-algebra. Welcome to lesson 3.2, Special Products of Algebraic Expressions, beginning on page 75 and going through page 78. There are a bunch of notes to be taken to lead into this lesson, so we'll begin right away. And the first note is actually note. So anyway, note. Some products involving squares of expressions, for example, a plus b squared and 2x minus 3 squared, are often used in factorization and in solving equations. Just check one thing. This square sign actually is in the wrong spot. Should be on the outside. There we go. Now it's squared. So a plus b squared should be that. Anyway, those two expressions are often used, and we've used them in our past lesson actually, but they are also used in something called factorization, which we will be coming up very shortly, which is used to solve certain equations. Now, there are three important products, and so these are the patterns. The first pattern is the first one that I mentioned up there and had to correct, a plus b squared. So whenever you run into that, it always turns out to be whatever is in the a position squared plus 2a times b plus b squared. And we'll see that practically applied in a moment. The second pattern is a minus b squared, which always turns out to be a squared minus 2ab plus b squared. You also see a plus b times a minus b. In that case, instead of distributing like we normally do, we can simply go straight to a squared minus b squared, because evidently, or actually that is what it ends up to be. If we recognize the patterns, we can save ourselves some steps by remembering these patterns. So furthermore, number one, perfect squares equals a plus b squared and a minus b squared. And the difference of two squares is always a squared minus b squared. Again, these will come and become more clear as we go through the lesson. So with all of that in mind, let's go to try it 6, which is at the bottom of page 76. Get this lined up correctly. Okay, have to squeeze this in a little bit. There we go. There, I think it's all in right now. Okay, so try it number 6. Tells us to expand each of the following. And in this try it, we're going to be concentrating on pattern number 1. So we have 4t plus 1, which is the a and the b position. So 4t plus 1 squared. So the pattern is a plus b squared, which we will turn into a squared plus 2ab plus b squared. So we're going to take the a, therefore, take the a, which is the 4t, and square it, plus 2 times the a times the b, plus the b squared. Okay, now I've taken this, used those numbers, and put it in that form using my a's and b's correctly. So I plug that into this formula, so to speak. Now I simply do what it tells me. So 4 squared is 16, t squared is t squared. So here's my new value for this, 16t squared, plus 2 times 4t, which would be 8t times 1, which keeps me at 8t, plus 1 squared, which is 1. And there is my answer to try it, number 6, letter A. Going on to B, I have that same pattern, 3x plus 2y squared. 3x is the A, 2y is the B. Plug it into the pattern. So therefore I will have 3x squared for the a squared plus 2 times 3x times 2y, because that's my a and my b, plus my b, which is 2y squared. Okay, now I go ahead and I start multiplying. And 3 squared is 9, x squared is x squared. So 9x squared for the first value. Now, remember, I can go in any order for multiplying. So first I'm going to multiply all my numerals. So 2 times 3 is 6, times 2 is 12. Then I'm left with an x and a y. So 12xy, which is 12 times x times y, which is all I can do. Then I take 2y squared, which 2 squared is 4, y squared is y squared, and that got erased a little bit, but that's my answer, 9x squared plus 12xy plus 4y squared. Try it number 7 moves on to the second pattern, because now within the value we have a minus. So 6 minus n squared. Now this minus just gets transferred down into the pattern, the minus. So it doesn't become a negative n, it becomes, the minus just transfers down in the pattern. And so the a is actually 6 and the b is actually the n squared. Okay, so our pattern this time is similar to the first pattern, the only difference being that the plus sign up here is replaced with the minus sign here. So plugging in my values, a squared becomes 6 squared minus 2, so that's where the minus goes down to. Now I plug in my b, or my a rather, 6, and my b, n. So minus 26n plus the b value, which is n squared. So I'm just plugging in to these positions what is in the first position there. This is the a and this is the b. And if I think you look at it a little slowly, a little carefully, you kind of get what I'm going after here. So anyway, therefore, if 6 squared is 36, I'm just going to keep the minus sign right here. Primarily because I have negative 2 times 6, which is a negative 12n, and then n squared, and there I go. There I go. So now again, we're going to use the same pattern because we have an a value minus a b value squared. A is going to be 8c, b is going to be 3d. So plugging it into that same pattern right here, pattern for that was up here. So a squared would be ac squared minus 2 a, which is 8c, b is 3d, plus 3d squared. So I'm just plugging in my a's and my b's in the right form according to the pattern. So ac squared is 8 squared is 64, c squared is c squared. So 64c squared. Now I have a negative 2 times an 8 times a 3. I'm going to do it this way. 8 times 3 is 24, and I can do that. Remember, you can multiply in any order. So 8 times 3 is 24 times a negative 2 is a negative 48 CD, plus 3 squared is 9, and then, of course, d squared. And there I have my answer. Remember, at any time, you can stop, pause, rewind, re-listen. There's a lot to follow here. Primarily, just memorize the patterns and plug in your values, just like you would a formula, and then go ahead and simplify it. So going on to try it number 8, it's in the middle of page 77. Get my pad lined up here, there you go. So now we're going to expand. Again, we're following pattern 2. So I have 7st, so that whole thing is the a value minus 1, which is the b value squared. So again, I am using this formula because I have that situation, and I'm going to plug my values into those positions. So I have 7st squared, because that whole thing is a, minus 2 times 7st times 1 plus 1 squared. So this is the interesting thing here. When this whole thing is squared, we have to square each of those components. So 7 squared is 49. Then we have s squared, t squared. Now I have a negative 2 times 7 times 1. So a negative 2 times 7 is a negative 14 st plus 1 squared is 1. And there we go. Moving on to try it 9, we go to pattern number 3. So now we have q minus 6 times q plus 6. Now the pattern is actually a plus b times a minus b. But remember, when you're multiplying, you can flip those around. So if it's a minus b times a plus b, it's okay, even though the original says the plus comes first and then the minus. Because it's multiplication, I can flip these two values around. And that's exactly what they did. This will translate into the a being squared and the b being squared. So I simply notice that in both of these, q is a, 6 is b. So a is q, b is 6. So I take my a and square it, and the formula says minus, and I take my b and square it. So q squared minus 6 squared. I actually can do 6 squared, so I keep on going. I have q squared minus 36. Another way, using the same pattern, will be in letter B. 11u plus 5v times 11u minus 5v. Notice that in this pattern, the a value is the same. In both cases, it's 11u, and the b value is the same. In both cases, it's 5v. But in one case, they're added. In the next case, they're subtracted. So I simply notice that a is 11u, b is 5v, and I square them both. So it's 11u squared minus 5v squared. I can actually square the 11. 11 times 11 is 121 u squared. And of course, 5 times 5 is 25, so it's minus 25 v squared. And there I have that one. Okay, turning the page, we have try it 10. Now we're going to evaluate these using special products of algebraic expressions. So the special products refers to all three patterns, 1, 2, and 3. We have in letter A, we're going to use pattern 2. Now this is interesting because basically it's taking a large number squared, and let's say you're without a calculator, because typically we would just use our calculator to square this. But we can use the pattern number 2 in this case, and I'll show you why it's 2 in a minute, if we square this by setting it up like this. So we can take 198 and round it up to 200, but we need it to be 98, so it's going to be 200 minus 2 squared. Now, if you remember, this is a minus b squared, which is pattern number 2. So I can just take this, plug it into the pattern, which is a squared, 200 squared, minus 2 times a times b plus b squared. So I just plug it into the pattern, and I have it. So now I have 200 squared, which is 40,000, minus 2 times 2 is a negative 4, times 200 is minus 800, plus 2 squared is 4. So I'll have 40,000 minus 8. I have to go in order of operations, so I subtract first. It's very tempting to add that first, but you can't do that. You got to go in order, remembering that subtracting and adding are of equal importance, so you do the first, whatever comes first. 40,000 minus 800 is 39,200 plus 4. My answer is 39,204. The next problem, letter B, we want to take 30.5 squared. In this case, I'm going to split apart my whole number and my decimal to 30 plus 0.5 squared. Now I have pattern 1 because A and B are added and then we square it. So again, plugging in into the formula, we have A squared, which is 30 squared, plus 2 times A times B plus B squared. So I go ahead and do it. 30 squared is 900 plus 2 times 30 is 60 times a half. So basically half of 60 is 30 plus 0.5 squared is 0.25. So again, order of operations, add the first two. 930 plus 0.25 is 930.25. Really pay attention, because when this comes up in your practice, you're going to need to do these type of problems without a calculator. You're going to need to follow these steps to prove you got there without a calculator. So use your rounding, use your splitting apart for pattern 1 and 2. Splitting apart is for 1, rounding is for 2. However, when you have a problem like this, where you're multiplying two numbers, you're going to go to pattern number 3. So you're going to round both of these in a way that would be 100, but to get back to 99, you would subtract 1, so this would be 100 minus 1. This you'd also round to 100 plus 1. So to get to 101, you'd have 100 plus 1. So now you have your A's and you have your B's. It just happens to work out. The A's are the same, the B's are the same. Pattern number 3, where A is 100, B is 1. So you square them both. 100 squared minus 1 squared. 100 squared is 10,000. Basically, it's just you square that number and double the amount of zeros. And then 1 squared is 1. 10,000 minus 1 is 9,999. So, having said all of that, again, you may stop, pause, rewind, rewatch the video as often as you need to. If you are having problems understanding any part of this, be sure to call. Your assignment is on page 78, 1, 2, 3, and 4. 1, 2, and 3, you're basically using one of the 3 patterns to solve the expansions. Number 4 is like what we just did in try it number 10, where you're going to evaluate using those 3 products of algebraic expressions to do it without a calculator. So no calculator on number 4. Just kind of think this through using those patterns. Okay, thank you very much. Do good math.